In the previous section, we covered the topics of installing Anaconda and set up the environment to get started with machine learning. In this section, we're going to go into machine learning, and specifically in this lecture, we are going to cover the different categories of machine and also deep learning. Now, there are three major groups of machine and also deep learning. They are classified as supervised learning, unsupervised learning, as well as reinforcement learning. Now, supervised learning really is trying to infer a function from labeled trained data or labeled training data. Now, supervised learning is really about training a model from pre-labeled training data. It's called supervised because you give the machine learning, the algorithm, a set of data where the labels or the desired outcomes are already known. So the ultimate goal here is to allow us to make predictions about unseen or future data. Now, unsupervised data here is such that there's no labels are given to the learning algorithm. You leave it on its own to find structure from the data that is provided, basically from the input provided. There are two different categories here. They are clustering as well as dimensionality reduction. The third category here is probably one of the most active environment or most actively researched recently and got a lot of attention, in particular last year. The reinforcement learning. Now, there are two types of reinforcement learning. One is utility learning, the other one is Q learning. So what exactly is reinforcement learning? I guess the best way to think about it is that it's neither supervised, meaning we don't give it any so-called data that is labeled, neither do we leave it unsupervised. What we're actually doing is we give it a so-called an agent to learn what is the so-called utility function. Now, the agent here, or the system, I guess is probably the easier way to think of it, learn the action and also the value function. So I guess the best way to think about it from a human perspective is that to every action, there is a reaction. Okay, there's a consequence to our action. So reinforcement learning is really about learning the action that you take, what is the actual corresponding result or the actual value or the corresponding consequences that come with that. So it developed a so-called expected utility or on average so-called returns or benefits that you get out of doing that. Okay, that's really Q learning, whereby utility learning is really the actual system or agent learn the utility function and it actually chooses the action that maximizes the expected utility, meaning highest return or highest satisfaction over time. So let's dig into supervised learning a little bit. We'll start with classified learning. I guess the best way to, and the most famous example is contrasting or trying to identify the pictures of cats versus dogs. Okay, so this is really the best example and is also the best one to illustrate the classification example. Now, what you can see here is that it's either a dog or not a dog. It's either a cat or not a cat. So what you have is actually a discrete class problem. It's categorical. And basically, it can be binary, meaning is yes or no, or it can be multi-class. Now, binary example will be cats or dogs. Multi-class example could be that it belongs to 0, 1, 2, basically a handwriting of digits. It could be 0, it could be 1, and all the way to 9. Now, what this picture here depicts really is that there is a group of values here, and there's also another group of values whereby these black lines segregate or separate between the two different types of value that you have here. The cross in orange and also the circle in blue. So the machine learning algorithm is able to segregate or bisect them, okay, between the two types. So this is still under supervised learning. Okay, so in essence, you already pre-labeled this before you train the algorithm, okay, before feeding it with unknown or new set of data. After you train it, it learns to identify that crosses, orange is one class, circle is another, and when you actually provide it with the data, it learns to identify the difference. Now, the next type that I want to cover is really the regression. It's another form of supervised learning where what you have here is that X is actually the predictor or the independent or the explanatory variable. And Y here is the dependent variable or the outcome. And the difference between the supervised classification, which is what we looked at earlier, versus this regression is that regression deals with continuous variable, and Y here is actually a continuous variable. Okay, so the relationship between the two is really what we actually try to get the machine learning algorithm to learn. Okay, so it's trying to learn how to use X to predict Y. An example of this would be house price. Okay, the number of rooms or the number or the size of the land or the size of the house. So basically, you're using explanatory variable to predict the outcome, which is continuous. So let's move on to reinforcement learning. Now, the idea of reinforcement learning, I already mentioned, is that you're trying to develop a system or an agent that improves performance based on the feedback or interactions with the environment. Now, what made reinforcement learning so suddenly come into limelight and become so famous is the fact that Google DeepMind and the game of AlphaGo has managed to beat Lee Santo in March 2016 over 3 games. It won every single one of the game, and convincingly as well. So what we can use reinforcement learning? There are a couple of examples. The agents or the system could be a program that learned to play Atari games such as Pac-Man. So in this case, the environment is a simulation of that game, and the actions are basically moving the joystick, up, down, stay in the center, left, right, and on it goes. So what you have here is that it basically learned to move away from the ghost. Okay, so that it learns to play that game from the observation of the environment and also receiving reward when it actually goes up in points, or negative rewards when it dies. Obviously, AlphaGo or the game of Go is another example of reinforcement learning. Another example that is quite prominent right now, whereby JP Morgan has been running this for about a year, but recently published it in their May paper, is that they have a reinforcement learning agent that can observe stock market price and decide how much to buy or sell every second or every millisecond, and then rewards here obviously are the monetary gains or losses. So here's another depiction of it. You have the agent or the system here, which is your neural network. In essence, that's the reinforcement learning algorithm. It conducts an actions or it takes certain actions and observe the environment via observations and observe whether it receives it in the form of rewards or punishment from the feedback that it received from the environment through the form of observation. Then it decide on an action and then compare the outcome against the reward definition. The reward definition it actually basically is what you need to define. Now, the reinforcement learning here tries to figure out what to do to maximize these rewards. Now, the rewards here, if you actually define your reward function as the cat jumping, or frightened, then your action might not be feeding the cat. Then it might be, recently or last year, people seem to enjoy throwing cucumber and scare the cats to get it to jump. So that's an example of the reward function. Quite a nasty one, but illustrate the point that I'm trying to make here. And we've so far covered supervised learning, reinforcement learning. Now I just want to talk about unsupervised learning. Now, unsupervised learning, it really is actually more of an exploratory data analysis tool. Some of the tools is clustering, meaning what you give it raw data in these green dots or purple dots and red dots, and initially you might not know what to do with it. So what you do here is that you feed these data or raw data to the unsupervised machine learning algorithm, and it actually clusters them into meaningful subgroups. You have a purple dot group here, you have a green dot group here, and you have this big red dot group here. So these could mean 3 different types of customers. These might be the male that spends a lot. This might be the female that also spend a lot, except that they take time to, this axis here could be time taken to shop, and also this could be, more time, less time. I mean, that index could be reversed. And also X here is in terms of the revenue from these clients. Less down this way, this could be young people. They can shop, but they don't have, they don't shop very long. But the problem is that they also don't provide a lot of revenue. So that is just an example of how you can actually use unsupervised learning. Now, unsupervised learning is really useful when you're actually dealing with unknown structure. You don't know how to interpret it. So basically what you do is that you feed into it and let it actually inform you what the actual structure is. Basically, this contrasts with if we know the structure, then you'll be using supervised learning. If you know the reward or the penalty that you're actually trying to obtain from, then you use reinforcement learning. So that is the end of this lesson on what the different categories of machine learning here. In the next lesson, I want to go into one of the famous Python library called scikit-learn and get into some examples so that you can get your hands dirty and play around with the different types of machine learning algorithm. Rather than learning it through theory, I want you to actually play around with it until you actually get an intuitive understanding of how it works. So let's get into the next video.